Thank you everyone for joining us. My name is Lindsay Wells. We're going to get started on the new user training for ICDS-ACI. For those of you that were able to download the presentation, awesome, follow along. We have the first half of the presentation is more informative to provide you with information on the cluster, as well as some kind of need to knows to get yourself up and running. Our users across the university come from drastically different backgrounds, both technical as well as their research. So we try to find a balance for, what to provide you in order to have you be successful running on our system. So we have some goals for today to learn about high performance computing. Again, this information is provided in the slides, so I'm going to kind of skip over some of that just because it's there for you to reference in the future if you need to. To learn about ICDS-ACI. So we reference our cluster by its name, so the Institute for Computational and Data Sciences, Advanced Cyber Infrastructure. Stay tuned because we are renaming the cluster in the near future. To learn how to run and monitor batch jobs. So for a lot of our users, this is going to be their primary utilization for the cluster. So we have an example towards the end of the presentation that we can work through together. And then learn how to get more information and help. So lots of users, HPC is new to them. A very helpful tool in their research, very powerful, but there is a learning curve. Even if you have a very strong technical background, I find that there's lots to learn and lots of resources out there to help you though. So a couple of notes moving forward to keep in mind, experience is the best teacher. So I myself was a new user about a year ago. So while I came from a very technical background, high performance computing and research computing, there was a learning curve there. So super exciting, but the more experience that you can get on the cluster, I think the more successful that you'll be. So spend time poking around, learning, taking advantage of the open queue. Those resources are free to you as a user, so there are some caveats, right? But in general, those resources are there for you to play around with, as well as my team. So ask questions. We're certainly here to help. One thing that's helped me too is reaching out to folks that were users prior to me there. So folks in your research group, instructors, so people that you're working with, in similar fields might have jobs that they've been able to successfully run on the cluster. Get copies of them. Try to run them yourself under your own environment. So practice, I would say, is the best way to really get yourself up and running moving forward. So when we talk about HPC, we're referring to high performance computing, so also known as supercomputers. Again, I mentioned our cluster's name is ICDS-ACI. We had a naming contest not long ago, so name Penn State's supercomputer. So this is the cluster that we're referring to when we talk about that. So what is high performance computing? In general, it's compute that is large. So thinking of our, the machines that we're on right now. So typically these are jobs that we might not be able to run on our single or dual core processors, lacking maybe a GPU. Maybe we need those resources. Maybe we need additional memory. This is where ICDS-ACI comes into play. So a large number of processors, a large number of runs, memory, storage, and run times. The next slide, kind of just like I said, we have our standard everyday workstation that we pick up for everyday computing. Typically, let's say, even a high-end workstation, some jobs that could take hours, days, weeks, months, could run in a matter of seconds, hours, weeks on our cluster. So, depending on what you're looking to run, your everyday workstation might not be able to complete those jobs in a timely manner, and that's where we come into play. So our cluster has, I think we'll talk about that coming up in the near future, 35,000 cores. So again, your standard workstation has obviously a small fraction of that. So it's comprised of 35,000 plus cores, 12,000 nodes that are interconnected in the Penn State Data Center, 20 petabytes of high performance storage, 200 plus active users, and we've been referenced in 3,000 plus publications since 2013. So getting started on ICDS-ACI, I'm assuming that those of you that are in attendance already have an account on our cluster. But real quick, for those that don't, you can sign up for an account using the link provided, so accounts.aci.ics.psu.edu. So students, faculty, staff are all eligible for a free account on the cluster. We'll talk about the resources that those free accounts give you access to. For students requesting access, as well as staff, we require you to enter a PI or an advisor. So they are listed as your sponsor. Some of your sponsors will have, or PIs will have access to various compute allocations, storage allocations, but for those that don't, you still get to run on the open queue. Notes for faculty. Faculty that are on our cluster, again, have access to great allocations, which are paid allocations that give you access to a certain amount of paid resources depending upon your needs. For those that have students that they'd like to give access to those resources, we do ask for explicit approval. So for the students out there in the audience, if your advisor has access to these paid for compute allocations, you can get access to those resources with his or her permission. Real quick, just to hop in, just so I don't feel like I'm completely talking to myself for an hour and a half. If anyone has any questions along the way, I welcome your interruption. So please feel free to interrupt me. You know, I am working from home, so I'm on my home network here. If there's any sort of interruption or whatever, please interrupt me, let me know. Awesome. Moving on. So I introduced you to a couple of members from my team that are here to help, as well as Justin from the RISE team. So this is just a slide for you to reference for the future for what some of our teams are comprised of. So I have a slide for the RISE team, which stands for Research Innovations with Scientists and Engineers. So these folks provide advanced technical support to the research community at Penn State. The team's led by Chuck Pawlowski, and then you can go ahead and see the RISE team members referenced on this sheet. So we have an amazing group of people that come from different backgrounds, so kind of spanning across different domains that we can, you know, that provide, again, advanced technical services. My team is comprised of myself, Chad, and Jason, who I introduced you to earlier, as well as a team of graduate assistants. And again, when we provide these assistantships, students are studying fields that we try to get students in different backgrounds so that we can help our various disciplines across the university. So references for the folks that are helping out in the iAsk Center. We also have a, which I didn't include in the slides, but lots of folks that are working behind the scenes. So from an operational infrastructure perspective, as well as our administrative staff. So lots of people to help you out, but iAsk is kind of your entrance into those resources. So a quick overview of the system. We reference ICDS-ACI, you know, in a couple of different ways. I mean, in general, this is our cluster, but our batch system is referred to as ACI-B. So when I say this, I reference the host name in this slide. So you'll see the host name, the fully qualified domain name of aci-b.aci.ics.psu.edu. So this is a helpful name to remember if you are accessing the cluster through an SSH client. So this is just to get you into the cluster. If you're accessing it from a terminal session, let's say on your Linux, Mac OS machine, or a PuTTY client in a Windows environment, this is the hostname that you would use to SSH into the system. So if you're accessing ACIB in this manner, when you log in and land on a head node or a login node. So I'm kind of like repeating myself here because of the importance of new users. I want you to understand the difference between a login node and a compute node, because login nodes are virtual machines. They do have a limited amount of resources. So let's say you're going to run an interactive job or running your code on a node or launching MATLAB and using it through, let's say, a non-graphical interface. You're going to want to do this on a compute node. The login nodes just don't have those resources to handle those type of jobs. You'll consume all the resources and you'll probably get an email from my team. So I say that, and we can talk more about that later on in the presentation, especially if you have questions about that. But just one thing to keep in mind, there's a difference between a login node and a compute node. So for those SSHing into the cluster, you will land on a login node, but there are a couple of different ways that you can go ahead and access compute nodes, again, which we'll talk about here in the future. Groups can purchase allocations or use the open queue. Again, this kind of circles back to your account that you got when you applied for an account on the cluster. So in general, you all have access to the open queue. The Open On-Demand web portal. So for many new users, and then for the purpose of our example, we'll be using the Open On-Demand web portal. This is it gives you a graphical depiction of the cluster. So you can start interactive sessions, so you can have an interactive desktop, you could have a graphical, a GUI interactive application session. You can also download and upload files of a certain size. We'll go through the different resources that Open On-Demand has to offer. So this is considered kind of one-stop shopping to the cluster. Back to ACIB. So again, if you're SSHing into the ACIB batch system, you can use the command from your terminal. So SSH with your user ID at the host name. Again, places you on a login node. I'm really not gonna repeat that again, but login nodes are, again, where you land on in the cluster. They're used for submitting jobs, but not for running processes. So if you're ever unsure where you are in your command prompt, it should show you what type of node you're on. Otherwise, you can type in the command host name and it should give you the fully qualified domain name of the host that you're on. So there's an example of what a name of a login node would look like. Compute nodes. So with compute nodes, again, we have various different compute resources and node types on our cluster. Now with compute nodes, if you request these resources, you'll submit a job. Your job will become available when the requested resources become available. And when your job is granted, you get the resources that you asked for in your job submission script or your interact command. So SSH access is restricted to nodes that your job's running on. So for example, let's say you have a job running on a compute node. You'll be able to capture that node's name by executing the host name command, and you could SSH into that node only while your job is running on it. So when your job's terminated, finished, completed, whatever, you would no longer have access to that resource via SSH. But while you have an active job on it, you should be able to SSH into that node. Compute nodes are used for production runs, high memory jobs, again, jobs that require no GUI. So we will go through an example of how to submit a batch job within our interactive session at the second half of this presentation. So this to me is really important, some need to knows on our cluster. So I think in order for users to be successful, it's important to have an understanding of the infrastructure. It's a very complex system, so by no means are you going to understand the ins and outs, quickly or easily, but it's nice to have something to reference, especially if and when you run into some issues with, maybe job run times or job submissions, jobs not starting, jobs getting suspended, stuff like that. So our cluster is made of, storage, compute. So in terms of storage, we have different file systems available. Storage is important for transferring data on and off the cluster. So knowing where your data lives. Compute. So for those of us that are running on the open allocation, so utilizing a free account, we have access to various node types. Depending on the resources you request for any given job, you could be placed on a specific node, or you could be placed on a node if unspecified based on availability. So it's important to know the different type of nodes that are available for your use. Again, there are different ways to connect to the system. So we talked about ACIB, how you can SSH into it. We touched on Open OnDemand, how for those of you that prefer a graphical depiction of the system, this would be your entryway into the cluster. Software, we have an extensive centrally maintained software stack. So perhaps a lot of applications that you're looking for may already be installed on the cluster. They might not be. We can help you with installing software, open source software, right? Licensed software, stuff like that. So in terms of the file systems, as a new user, when your account was created, your account from a storage perspective is comprised of a home directory, a work directory, and Scratch space. So your home directory, let's say you SSH into ACIB, or you start an interactive desktop session and launch the terminal, you are by default in your home directory. You have 10 gigabytes of storage provided through your home directory. Your work directory, there's a symlink in your home directory to your work directory, but the path provided in this slide will get you directly to that from any point, from wherever you are within the file system. So your storage, you have a 128 gigabytes of backed up data. This can be shared with anyone. So what that means is, I'll use myself for example. Let's say that I want to share some data with Jason that lives in my work directory. I would reach out to the iAsk Center and just say, hey, I'd like to share my work directory with Penn State user ID person. Go ahead, thanks, great. So we can go ahead and add that member requested to a group that's designated to you, and that would give him or her access to your storage work user ID space. So that space can be shared, that's for collaboration. Scratch space. So everyone gets unlimited Scratch space. There is a 1 million file limit, but no size limit in terms of gigabytes of storage. Scratch is located at the GPFS file system Scratch user ID. Again, there's a symlink for work and Scratch in your home directory, and your home directory is where you will land when you access the cluster. One thing that I will repeat multiple times with Scratch is Scratch is not backed up. So when we say it's not backed up, we mean it's not backed up. We've had a couple of folks reach out with very important files in their Scratch space that unfortunately they had forgotten about for a little bit, or whatever, hadn't been modified in that 30-day period, and they lost that data. There is no backup of Scratch whatsoever. So these files cannot be restored. So after 30 days, lack of access, lack of modifications, those files are deleted. Fortunately, we do back up home and work, and if you were ever to accidentally delete something or need to revert to a file or directory in a given time frame, we should be able to restore that type of data for you. But again, Scratch, it's not backed up and it can't be restored. So while this is a great place to run jobs from, do not keep anything important in your Scratch space. Again, don't leave anything on Scratch. So as I mentioned before, Work in Scratch should have symlinks in your home directory. So this is just a quick shortcut to get you to those paths. But if you ever need the absolute path, it's provided in those the previous slides. So from a group perspective, for faculty that's in the audience or for students who can make recommendations to their faculty and research groups, groups can purchase storage in 5 terabyte increments. Groups can also purchase archive storage. That's for more long-term storage, backup and long-term storage. This type of data for the archive storage is available on the data manager nodes. The data manager node, we will mention in the future, is great for data transfers. So it's just another host name to reference for those of you that are using the cluster for storage purposes. So I mentioned compute node types. So we talked a little bit about the file system in the previous slides. This slide I'm pretty much going to leave for you for reference. So we have various ACIB node types. So again, I'm going to just assume that most of you are utilizing the open queue. Even for those that have compute allocations, you definitely would still want to use the open queue for some testing purposes, or other things. So you have access to basic, standard, and high memory nodes. The GPU nodes are only available to those with paid allocations. So if you're unsure if your PI has access to those resources, if you need a node with GPU acceleration, feel free to reach out to the IASC Center. But otherwise, as a user on the cluster, you have access to basic, standard, and high memory nodes. So when you submit a batch job, if not specified, you'll be placed on a node based on availability, resources requested, and whatnot. So the open allocation, which I've mentioned multiple times, is available to all users, all non-GPU nodes that we mentioned in the previous slide. We do get a good number of tickets for folks that say, hey, my job was running, but I'm not really sure what happened to it. It's showing an S status, an S in the status, let's say when they try to QStat or check on their job statuses. S means that your job is in a suspended state. So jobs that are running on the open allocation are eligible for preemption, meaning they can get suspended. So these are shared resources. There are paid allocations that take priority over those resources. So what that means is, let's say you are running on the open allocation on a standard core node. Somebody with a great allocation submits a job, there's limited node types available, there's limited resources available. Your job could get suspended if there's limited resources in order for that guaranteed response time job to start. So with those great allocations, they are limited to users authorized by a PI. They have a guaranteed 1 hour start time, as long as, no other jobs are running within the resources available on that allocation. You can run them in burst mode, which could be up to 4 times the number of cores that are available on that specific allocation. And the usage of that allocation is governed by a 90-day sliding window. So let's say, just for an easy example, I use all of my resources up somehow, or half of my resources up somehow today. And those resources would be replenished that I use today, 90 days from now. Connecting to the cluster. So I'm sure that most of you, well, I guess I shouldn't make any assumptions. Let's say that the majority of users are running on a Windows or Mac OS machine. Some Linux users out there. So for us Linux users and Mac OS users, you have the native terminal client that comes with the OS. So this will, if you launch the terminal client and SSH into ACIB, that gets you directly onto a login node. So that's one way to access the cluster. For other OSs like Windows, for example, I think PuTTY you can use PuTTY on Linux, and I'm assuming Mac OS as well. You can also use that as an SSH client. For Windows, there's also like, why can't I think of any Windows clients right now? PuTTY is the recommended one. Open on Demand. So with Open on Demand, I'm going to show you in just a bit. It also has a browser-based terminal, so you actually don't need the native terminal client or even to install PuTTY. So it's just another way to access the cluster through a web-based terminal. Again, just for reference, if you're going to SSH into the cluster, there's the command that you would use to SSH into it. So you use your user ID when you are entering your password. One thing to note, I'm thinking PuTTY does this too, but one thing to note is when it prompts you for the password, you'll start typing. Some OSs give you feedback like, hey, I enter an asterisk for each character that you enter. Linux is like, nope, you just type blindly. So you won't see the little star asterisks that show up as you enter your password. So that's normal. Getting started with the terminal. So again, for those that are submitting batch jobs on the cluster, we like to get you familiar with the terminal. So some simple commands. These again are just kind of for reference. So I'm kind of going to zoom through these, and I would be happy to, if anyone has any additional questions about the Linux command line, we can go over them. So the command line framework, when you know, and I kind of do want to switch over to a terminal, but I'm not confident in my screen sharing abilities right now. So if anyone has any questions about the command line framework, please let me know. Hoping everyone understands what I'm saying when I refer to a terminal, but I will get to that here in the near future. So on this slide, the terms are highlighted to, so like orange is the command prompt, blue is the command, flag is purple, yellow is the output. So on a command line, we issue commands, we can throw various flags at it, kind of telling it what to do with the output. And then we issue a command by hitting enter, and then we're provided with output based on what we executed. So these are just some examples of if we ran the mam list funds command. So this is telling, let's say, this is telling me what resources I have access to and what the funds are that are available on these compute allocations. So for those of you that have a, I mean, well, pretty much anyone can run this, but for those of you that have compute allocations, if you're following along, go ahead and execute that mam list commands and the -h flag, which should provide you output similar to what is on the screen there. Basic commands to get you started. So if anyone's playing around in a terminal, I find it really fun to navigate through the file system. There's so many different commands that you can throw at the terminal, at a command line, but these are some simple ones to get you started. So as I mentioned, let's say you're SSHing into the cluster or starting an interactive desktop session. When you are presented with your command prompt, you're in your home directory. So if you typed in pwd, it should show you the absolute path on our cluster of your home directory. The ls command would list the contents of that directory. If you are indeed in your home directory and you issue the ls command, you should see a scratch folder as well as a work folder. cd would change the directory. So if you cd scratch, that would enter you into your scratch directory. And then again, if you did pwd, it should show you the path of your scratch directory there. Copy files, this is just the simple copy command. You're copying, a log file to a new log file name. Just some things to play around with. For those of you that a command line terminal environment is new to you, I didn't provide links in the presentation, but a really good resource for getting up and running on a Linux system or a command line environment is LinkedIn Learning. There are so many, there are quick resources, so a couple of minute videos to extensive training, and a lot of it's interactive. It'll really help you get up and running if this is something that interests you. Other commands that you may find useful. So let's say you find yourself doing the same thing over and over again, but maybe the commands aren't sticking with you. The history command, this tracks the commands that you've executed within your terminal session. So you can refer back to your history log file and it will tell you commands that you've executed over time. You can grep, so you can search, you could do a history pipe grep, and then maybe a keyword of what you're looking for, and then it'll kind of narrow down your search resource, your search for what you're looking for in your history file. But again, just some commands to execute if you're playing around in the terminal environment. Special characters, the tilde. So if you are anywhere within the file system, let's say you're lost and you just want to get back to your home directory, you can do a CD for change directory space tilde, which will get you back to your home directory. So that's a sure way to get back to a familiar place. Again, I'm not going to really go through those, but just a reference point for those of you that are following along. Linux has a very extensive manual. So meaning use this when you need help with a command, or you have a command to issue, but you aren't sure of, let's say, flags that can be thrown at it, or you get an error when you try to execute a command. You can use the manual for example, in this case, I would be running the man command on du for disk utilization. So this will give me the manual on the du command. So if you were to execute that command, for those that are following along, man du, you can use Q to exit. So once you're done with the manual, pretty extensive, scroll through it, move arrows up and down, mouse, whatever, and then Q to exit. So tons of information. Yeah. So our cluster has a central software stack. Modules are used to allow multiple versions of the same software in the software stack. So I'll use MATLAB, for example, because it's probably one of our most utilized applications. So we have 2 versions of MATLAB available to users on our software stack. So I think right now we're running 2019A, which will be, updated in the near future. And then also 2017 A or B. But to see what software modules are available to you, you could execute the module avail command. Let's say you wanted to see if a specific application was on the software stack. Module spider, and then whatever software you're looking for, execute that command. If it's there, it'll tell you information like VASP, for example. It will tell you information on the version of VASP versions that are available on the software stack. To load a module load, whatever the modules, whatever the software's execute command is to launch the application. So ANSYS, for example, would be the command provided there. MATLAB, so using MATLAB again as an example, which you'll see that MATLAB, the default version, so if you ran a module spider MATLAB, you would be presented with both versions of MATLAB that are available on our software stack. Excuse me. You would also notice a D indicated next to the default version. So if you executed the command module load MATLAB, you're going to get the default version. If you want to specify the version, so for example, if you didn't want 2019A and you wanted the prior release, that's available on the software stack. You would just go ahead and execute the module or the application name / version number. And again, you can bring your own software. So we've had pretty good success getting users up and running on the cluster with their own software. So, obviously with a central software stack, we can't support everything. We do provide our licensed software to users. We try to update it on a fairly regular schedule, so a 6-month update schedule. I don't want to say that we're a little bit behind, because I don't think that would be fair. We are working on updating the operating system of the cluster in its entirety. So right now we're running Red Hat Enterprise Linux 6, I forget what version, 6 dot something, and we are updating to RHEL 7. So when the updated OS comes out, there will also be an updated software stack. So meaning, you know, MATLAB, I was just talking to them about Abacus. So the 2020 version will be released once we deploy all of our nodes in the new RHEL 7 environment. So that's kind of to come. In terms of you bringing your software, you come to the iAsk Center. I mean, feel free to install things yourself, play around. There's tons of documentation out there on how to install software. But, you know, one thing that we need to know, open source versus licensed. Some licensed software can be installed on the cluster. Others, you have to have a specific license to be able to install it in our environment. So just stuff to keep in mind when you're installing software. Also, there's, you know, different ways that software can be installed. So using a precompiled binary, like that's awesome, right? It makes it a lot easier for you, us, whatever. But you can also compile software from stores. User level package managers, they're great. And again, this is all something that iAsk can, you know, help you out with if you have issues getting that software installed. Containerization, another really important tool to us. We have Singularity installed on the cluster. So again, right now I mentioned we're running RHEL 6. We do have some software that requires libraries greater than or newer than what we have on the operating system, or just, you know, it requires a greater release to the OS, but we can still install the software in a container. So most things are very doable on the cluster. And again, our staff is here to help. Quickly, I mentioned the data manager nodes before, just another host name to keep in mind, especially when it comes to data transfers. So, hey, I mentioned you can SSH into ACI-B, it gets you on the batch system, awesome, like start submitting jobs, whatever it is you're gonna do. But on the data manager nodes, this is kind of where you're gonna want to go for data transfers. So let's say you SSH into that host name, the data manager host name. You're gonna land on one of 3 nodes. They're all, from a user's perspective, identical. So they have, they should have homework, scratch, and group mounted on them. And then I mentioned earlier, archive, right? So archive storage is available to those with allocations. So this is where archive lives. So if your research group mentions, hey, you have access to archive storage, you have to be on a data manager node in order to access that space. Best practices, yeah, transfer to ACI and then to archive. I think from maybe an efficiency standpoint, and then compressing your files is also kind of best practice when transferring data. Not all of you are going to use the command line to transfer data, so you could do a SCP, rsync, SFTP, whatever. You can issue those commands kind of from an SSH session and execute that way. But for those of you that are looking for, let's say, a kind of drag and drop data transfer client, you have tools available to you. These would have to be downloaded on, you know, your local workstation. But WinSCP is a file transfer client, FileZilla. We also have, which I'll show you in a bit, through the Open OnDemand portal website, you can transfer files. Again, I think there's like a 10 gigabyte limit. I don't know, nothing huge. You wouldn't want to do that through a web interface anyway. But again, just kind of graphical tools where you can drag and drop through to do the file transfers. If you're doing large file transfers, Globus is an excellent tool to use. It's on the research network. It's a good pipeline to transfer data. It also has a client. So we'll use your machine, for example. Let's say you've got, I don't know, 50 gigabytes of data on your laptop that you wanted to transfer to ICDS-ACI. Globus would be a good resource. Globus would be a good resource to use. You can install the client. It does have a drag and drop feature for transferring files from one host to another, but there is a little bit of a configuration. A machine has to have a Globus endpoint in order to transfer that data. But for those of you that hear that name, again, being a new user, I'm kind of throwing terms out there that if you ever hear someone say, well, what about Globus? You can be like, yeah, I've heard of that before. And then kind of just Google Penn State Globus and it'll get you all back to us. And then the Open On Demand portal. I provided a little example for if you're using the command line to copy a file or transfer a file. Again, this is just another thing where if you do prefer an application, so like a GUI drag and drop kind of thing, things to keep in mind. So not all of these applications have the right protocols as the default. So you might have to change a protocol in order to be able to connect to a node or transfer that data. You know, default port's usually 22 for these types of transactions, but things to look for if you run into issues transferring files on these clients. All right, cool. So yeah, quick introduction to Open On Demand. It is an NSF-funded open source HPC portal developed at the Ohio Supercomputing Center. So they've developed this awesome tool. We've implemented it into our infrastructure and environment and got it up and running for our users. For those of you that might have been present back in the day, we retired its predecessor was Exceed On Demand. We retired that, I think this time last year. So it's been a really good replacement for that kind of deprecated resource. So again, to me it's for those that aren't comfortable or, you know, non-Linux users or just people that prefer a GUI or need a GUI for the application that they're using. Open On Demand is an excellent resource to get you started on the cluster. So what this provides is GUI sessions, right? So you have an option to start an interactive application for a subset of applications that we have on our software stack. You can do transfers, so file transfers. You can easily download a file, again, if it's of reasonable size, from the cluster to your local machine through that browser. You can also create, submit, and monitor batch jobs through this tool, as well as view allocation limits and cluster utilization. So looking at the slides we have next, so I'm hoping people are following along. And if so, now's the perfect time to go to, I guess we can talk about that real quick. But yeah, for those of you that are following along, does anyone not know how to access Portal? So in the chat client, it's, Jason, can you enter the URL for portal.aci.ics.psu.edu? I'll get there in just a sec, but we are going to submit a batch job here coming up shortly. Why? So I'll give you 3 different, we're going to work off the same example, but I'll give you 3 different use cases for a similar example, right? So we're going to do, it's a simple hello world job that we're going to do through a GUI, and then we're going to do through a terminal. So we're kind of just going to say, hey, I don't want the graphical application, but I still want to watch my code run within my terminal session. And then we're going to submit it as a batch job where it's something that I can submit my job submission script, walk away, and come back to, at a later time to the output. I guess the slide said, hey, why do we want to submit batch jobs? Yeah, so these resources are not shared with others. So let's say you request one processor and 10 gigabytes of RAM. Those are your resources once they're allotted to you and set aside. Those are your resources for the duration of that job. You have more amount of resources available through this type of submission. Again, you can kind of just submit things and walk away. All right, so I think I'm gonna exit out of here. Okay, so Jason, can you see my my webpage? So I should be sharing Open On Demand homepage.
Yeah, I can see it.
Okay, excellent. So those of you that are following along, I mean, I'm gonna pause for just a second to give anyone the opportunity, like if someone's like, where are you? Please interrupt me. Cool. I'll take silence as a good thing. All right, awesome. So following along from the slides, because I'm not sharing my presentation anymore, I'm going to be on slide 31. So the hands-on MATLAB running as a GUI. So before we do all that, real quick, so I mentioned quite a few times about file transfer through Open OnDemand. So this is the home page of portal.aci.ics.psu.edu. So again, Open OnDemand, portal, yeah, maybe you'll hear those terms interchangeably, but this is what I'm referring to when I say portal or Open OnDemand. So I'm going to start with the Files tab. For those following along, go ahead and click on your Files tab. So yours might look a little bit different than mine, only because we have access to different resources. But one thing that you all do have in that dropdown is your home directory. And that's kind of where I always go. I mean, obviously, yeah, I've been using the cluster for about a year, so I know the paths to the different storage allocations that I have access to. So you might not, but you should be able to click through and navigate to them. So hopefully you all can see my home directory. If not, holler at me, and yeah. But again, for those of you that kind of like that graphical depiction, you can go ahead and click through things. You can expand on things. I mentioned that you have links to your Scratch directory, as well as links to your work directory. So those are symbolic links that will take you directly from your home directory to those spaces. So, you know, your home directory is a good place to start. And then now you can see what's in my work directory and all that fun stuff. So let's say I wanted to download this new user training, which I'm going to share with y'all soon. I could simply highlight that directory and click download, and it would begin downloading within my, my browser. So pretty cool, pretty easy, very straightforward. Now, I have access to some storage allocations, and many of you will too. So for example, if you have a research group, if you're a member of a research group where your PI has a storage or compute allocation, you've got group storage on our GPFS file system. So if you like this files tool, you can go ahead and navigate throughout the file system if you know these paths. So for example, you could click on the go to icon in the upper right, and if you know the directory path, you can just type it in. So GPFS/group / your PI's ID, in this case, mine, and click enter. And that will go ahead and take me to our group space. So just another way to kind of navigate through the file system without having to do it from a terminal. All right, back to the portal homepage. I'm going to X that out. Jobs. So for those of you that are maybe a little bit more familiar with how to monitor your jobs, you can do it through a terminal using a show queue or QStat command, but you can also use the jobs tab. So it should show you any active jobs that you have running on the cluster right now. I have 3 jobs up and running. It looks like I'm using them all on the open queue, and they are all running. Awesome. I mentioned that jobs running on the open queue are eligible for preemption or suspension, not ACI inodes, but other node types. Again, if I saw a status of S, it means my job's suspended. Will it start again? Maybe. Okay. Couple other cool things, user tools. So graphical cluster accounting. So what this does, it shows you the resources, the compute resources that you have access to, and the number of, let's say, hours available or their expiration. So what you're looking at right now is different compute allocations that I have access to, the number of cores, basically the specifications, the node type, and whatnot. So you can grab that all through the user tools graphical cluster accounting. You can also check on your file system quota. So what this is good for is, again, as a user, right? So whether you have access to these paid allocations or not, you still have that strict limit of 10 gigabytes of storage to your home directory. And you know what? I mean, I don't write a ton. I don't generate a ton in my home directory. I usually do it in my workspace just because, you know, I'm either using it for collaboration or just in general, I have more storage there. But some applications that are used will, by default, write to your home directory. And depending on the type of jobs you're running, 10 gigabytes can fill up quickly. So you could run into issues where you're like, hey, it says that I don't have any storage available. What's up with that? Yeah, your home directory might have filled up with, you know, applications writing to that file and perhaps even to a hidden directory. So you can check your quota through the Open OnDemand portal. Okay. And then I also mentioned, for those of you that don't have a native terminal client, so Linux users and Mac users will have that, but let's say on a Windows machine, while sure you have the command prompt, it's not going to get you to SSH into our cluster. You can use the cluster's ACI shell access. Ooh. Okay. And what this does, Jason, can you give me a thumbs up if you can see my terminal?
Yeah, I see it.
All right, sweet. So what this does is this gives you access to a terminal-like environment through the web interface. So I had actually tested this just before the presentation. So when I first tested it, and for those of you that are following along, you should be presented with a two-factor authentication prompt. So it should prompt you with whatever options that you have elected in your 2FA account. You do have to 2FA in order to access the cluster. And then once you authenticate, as you can see, you are on a, I was trying to make that bigger. You're on a login node. So again, PWD will show you the absolute path to where you land. So great, I'm in my home directory. LS will give you the contents of your home directory, change directories. So if I wanted to go to my work, will put me in my work directory. So stuff like that. Now you can play around with those commands that were provided in the previous slides. To get home, I mentioned the handy dandy tilde command from anywhere in the file system, cd space tilde, puts you back in your home directory. The host name, just another command that's important to know. It tells you what type of node you're on. Hey, I'm on a login node. I don't really want to run anything resource intensive. You know, maybe I'll submit a job to a compute node. So this is kind of off topic, but while I'm here, for those of you that are submitting jobs, like you find yourself using a terminal often, and maybe testing things out on the login node, we have a really simple way to put you onto a compute node. Now, it's a single command that it's like a wrapper command. So I think by default it's 4 cores, 16 gigabytes total RAM, and maybe like 8-hour wall time. So if those resources are so if those resources are sufficient and you just want quick access to a compute node, you can execute the interact command and it will submit a job to the cluster. So that's basically the same thing as queue subbing something, or you know, queue subbing a long interactive command. So queue sub -I. It's just an easy way to say, hey, I want access to a compute node. I don't care what type. I just want to test out some code. Here we go. Okay, so that's that. Gonna hop back to the presentation so we've got about a half hour left to go through the interactive part. So to go through our MATLAB examples. So for those of you that don't have an interactive desktop job up and running, or maybe have never submitted one, click on the interactive apps menu And the first selection should be ACI Interactive Desktop. Go ahead and click on that. I might have a couple of different options than you, but just note the GUIs that are available as well as the desktops. So ACI Interactive Desktop should take you to a submission screen that looks like this. So a couple of fields to fill out. It will save your previous request. So this is what I requested the last time that I was on here. For desktop environment, I recommend you sticking with the GNOME 2 desktop environment allocation. For these purposes, go ahead and use the open allocation. Unless you have access to compute resources, I just really don't see the need to use them. I'm gonna request an hour just because, hey, we've got a half hour left. And then the less resources, usually the quicker the job starts. Any kind of node type would be sufficient for this. So go ahead and select your node type. I would say either maybe basic core, standard core, or even an ACII node. It doesn't seem like they're too heavily utilized at this time, but I'm not looking at it, obviously. So go ahead and select that and click launch. I'm not going to do it because I've got a bunch of jobs running. But while we're waiting for your jobs to start, I do want to talk about some key items for this ACI Interactive Desktop. And again, just kind of making some key points where if you ever run into issues, maybe it'll stick with you. So desktop environment, GNOME 2 seems to be what most users use, kind of the standard for the Linux type desktop environment. Yeah, at least, okay. Allocation, so if you have access to other compute allocations, you can certainly select those, right? Make sure that when you select an allocation type, the node type aligns. Maybe it'll throw up an error, it probably should, but if it doesn't, make sure the node type aligns with the node type that your allocation's for. So for example, this allocation is an SC allocation. So that's a standard core allocation. I want to make sure that I'm selecting a standard core node type. With the ACII nodes, so in the drop down, you'll notice ACII, and you'll also notice a description. So, hey, these are ACII, we refer to these as interactive nodes. So they have GPU GL acceleration, so kind of like VGL, or yeah, VGL acceleration. Ugh. So some graphical applications require this type of rendering. So if you're doing 3D rendering, let's say in Console or ANSYS or something, you're going to want to request an ACII node type because they have minimal, but they have graphic cards that utilize GL acceleration that makes that type of rendering possible. So again, keep that in mind. If you're doing any type sort of like graphical rendering, you're going to want to use an ACII node. The ACII interactive nodes are only available on the open allocation. So these are, you can't purchase an allocation for these interactive nodes. They're available to all users. Definitely a limited resource, and because of the limited resources, we've had to place restrictions on them. So you can only at any given time have a single ACII interactive job running. So if you try to, let's say me, for example, I have a job running on an interactive node. I could not request, I mean, I guess I could request it. I think it just sits queued indefinitely, but my job will never start on an interactive node with another job running. So keep that in mind. You could only have a single job running on an ACII node at any given time. Okay, so I'm going to go ahead and launch my job. And I am presented with my GNOME desktop environment. I have minimal stuff on my desktop, totally fine. Your desktops might look a little bit different if some of you have added shortcuts or files or whatever. But in general, this is what your desktop environment should look like. So is there anyone following along that hasn't been able to start an interactive job? Okay, I will assume all is well and good. Like I said, feel free to interrupt at any point. So in order to access a terminal through your interactive desktop, click on Applications, System Tools, Terminal. For some reason, the resolution is slightly blurry using Chrome, so you might encounter that. I think it was like the most recent update of Chrome. Something is interfering with the resolution. There are options to update your, to maybe modify your resolution, but I haven't found great success. But anyway, use Firefox and it'll be fine and dandy. So in order to grab the example, you will have to, hopefully you have the slides with you. You are going to want to execute the copy command that's going to put the new user example in your work directory. So for those of you following along, let me make this a little bit bigger. I just don't want it to be, I don't want it to be totally blurry, but yeah. Okay, so hopefully you guys can see that. So right now, just for good measure, I'm going to show you that I'm in my home directory. Sorry, that's bothering me. Really. All right, cool. So ls, home directory, yep, got all that good stuff. You see that my symlinks are highlighted. So I've got, I don't know what color that is, teal. The symlinks are that kind of aqua-y color. Anyway, I've got a couple of my home directories. So I'm going to go into my work directory, right? So cd work. When I'm there, I want you to execute the following command. Okay, so this is a copy command. It is taking the new user directory that is located in this space, so the GPFS space, and it's copying it to your current working directory. So for those of you that are following along with the slides, it's probably easiest to copy that command, but one trick or feature, whatever you want to call it, within Open OnDemand, you can't Control-C, Control-V, like the shortcuts just don't work because your browser is kind of like hijacked. So like your browser shortcuts kind of take precedent over the terminal. So again, just, yeah. But if you look to the left of your screen, and hopefully you can see mine, there is a little caret pop-out menu. If you click on that and click on the keyboard, you can, so from the command that you've copied in the slides, you can go ahead and then Control-V or right-click paste or whatever it is you do to paste your commands. You can copy it into the clipboard. So again, I feel like maybe like old school applications, that's how you used to copy and paste things into a clipboard. I don't know. But yep, so that's how you copy and paste within this interactive desktop environment. So once it's in your clipboard, you can then do your Control-A, Control-C, minimize your clipboard, and then you can right-click and paste it into your command. So go ahead and execute that command. And so if anyone has issues copying that, again, you should be in your work directory, especially if you're following along, because that's where we keep going back to these examples. Let me know if you're running into any permission issues. Again, for those that are following along, we are on slide 31. So what I would do then is now you see, all right, you see that I have a new user directory, and so should you within your work directory. So let's go into that new user directory. And once in there, execute your ls command to list the contents of that directory. And you'll see the difference between files and directories, right? They're colored differently, just kind of like the symlinks were. So MATLAB EX is a directory. So go ahead into that directory. ls. Okay, so we have two files in our MATLAB example directory. Sorry. Question. Yes, I will definitely be sharing the video and I'm available for questions afterwards. Thanks, Jason. Okay, so we are, as you can see, in that MATLAB example directory. ls will show you the contents of the directory. ll will also. Again, it's just another way to see maybe more information. All right, so in order to view a file, we can view one real quick. We'll view the Hello World MATLAB script because that's what we're going to be running here shortly. So you can run a more on the MATLAB job submission script or the Hello World file. So go ahead and run more just to see how simple it is, what we're actually going to be running here. But cat will do the same, just different commands that will achieve the same outcome. So you see the contents of this directory. Let's go ahead and do it on the PBS file as well. That will be our job submission script that we'll use for a batch file. I'm sorry, for submitting a batch job. So you can go ahead and see the commands that we're executing and whatnot. You'll notice that I kind of keep executing this clear command. So what that does is it just clears my screen. So the viewing pane, I'm not like actually clearing the history. It just gets rid of what's within my viewing pane. Okay, so with that, we're going to go ahead and prepare our environment. So slide 32, I don't have anything running, but for good measure, just anything that could interfere with the usage of the MATLAB application, I'm going to go ahead and execute module purge. So this will purge or terminate any other modules that I have running at that given time. Cool. So one thing that I do that's not on there is, so previously we talked about the module spider command. I'm going to issue a module spider for MATLAB. Hopefully it doesn't take forever because that would be super, it's not really in here. But what should come up is it should show you the different versions of MATLAB that are on the central software stack. So again, I mentioned we've got a version 2017, and for the purposes of this exercise, 2019A. So for those of you that are following along, go ahead and execute that. Mine seems to be angry about something, but oh, rebuilding the cache, great. Okay, so we ran our module purge command. Now go ahead and execute module load MATLAB. And then for those of you new to a terminal environment, tab complete is an awesome tool. If there are multiple options for execution, it will actually provide those to you. Sometimes there's far too many because maybe you didn't issue enough of the command. But yeah, okay, so we have right now MATLAB. So if you execute the module list command, MATLAB 2019A is currently loaded, but now we want to launch it. So for the purposes of this exercise, we are going to not do that. We're going to launch the MATLAB GUI. So execute the MATLAB command after the MATLAB module is loaded. And this should start the GUI of MATLAB 2019A. So you should be in your home, or I'm sorry, you should be in your work directory in the MATLAB example. So as long as you didn't change anything, you should see the Hello World MATLAB script already within your path. So for those of you that use MATLAB, go ahead and execute the Hello World script. For those of you that don't, you can right click the file name, so the hello world.m, and click run. Otherwise you can type in hello world and it should run your script. So that's really it. That just gives you, again, the example, super simple, but this is how we would utilize the MATLAB GUI to run a script. Okay, so slide 33 should show you, you should be able to see my screen, should show you the output that we had, right? So we're running this in a GUI, in GUI mode. Next, we are going to run it in a terminal. So you can go ahead and you can X out the MATLAB application using the application X, or within your command line, you should be able to Control C, and that will terminate it as well. Okay. All right, so running it in a command line. So why would we run it in a terminal versus a GUI? Again, I understand wanting to use a GUI, but sometimes we don't need all that overhead of resources. and we just don't need the interaction. So it certainly speeds things up if we don't need the overhead of a GUI. And then this is also kind of a stepping stone to submitting a job. So basically what we're going to be doing in this next step is what you're doing in your job submission script. So for good measure, go ahead and execute module purge again. So let's just start fresh. So if I run the module list command, no modules should be loaded after you execute module purge. All right, super. Module, we're gonna run module load MATLAB again. I wanted to show you the tab complete because I mentioned, hey, it shoots out other options if there are other options, right? So you can see we could have used MATLAB 2017B, and then again had my module spider MATLAB command provided output. We would have seen that the default is 2019A. So simply executing the module load MATLAB command will suffice for these purposes. So now if I run a module list command where you can see that MATLAB 2019A is loaded, whereas when I ran it after module purge, nothing was available. Okay, so for those that are copying the command from the slide, again, copy from the slide, use your clipboard tool. I'm going to use it again just for good measure. Go ahead and use the clipboard, copy your command into it, Control A, you can right click and copy. Control C for copy or right click copy. Collapse your menu and then, oops, not that. Okay, and then right click and paste. So here, I am telling it to, hey, don't start in a GUI, right? I don't want to see the display. I don't want your fancy splash. I only want a single compute thread. And please execute my hello world MATLAB script. So that's exactly what it did. So in this example, we basically just eliminated anything graphical. And then we were provided with MATLAB through a terminal session. So right now I'm running MATLAB. I can execute any of my MATLAB scripts from within this terminal session, and it will interact just like MATLAB does if you were using their terminal within their application. So again, if you don't need the overhead of a GUI and you're just looking to do something like this, this is kind of, your segue in between a graphical application and then, submitting a job. So next up, we're going to go ahead and submit a job. So where are we in the presentation? So slide 35 will tell you about the command that you executed. So again, MATLAB executed MATLAB, no display. Hey, we don't want the display, blah, blah, blah. One other thing that we can do, so in this example, you saw that our output was presented to us in the terminal. You can direct the output to a file. So all you would do here is, for those of you that are looking to re-execute the command, hit your up arrow. That way you don't have to type it in or copy it again. And then to direct any sort of output to a log file, you can use the like a greater than symbol, and then whatever you want to call it. So log.matlab in this case. So then again, it's kind of running through our script. So launching MATLAB, running through our script. And then instead of directing this output to me, it directed it to the log.matlab file that I specified. So, again, for example, you can look at that log file, just view it, and there it is. So pretty cool, pretty simple. Batch job, right? I know you're all super excited to submit a batch job. Maybe some of you are already doing that. That's awesome. For those of you that aren't, I think this is a great way to submit your first batch job. So let's go ahead. We are still in our MATLAB example directory. So ls, let me clear my screen real quick. All right, cool. So let's go ahead and look at that job one more time. So cat more MATLAB, yeah, awesome. So again, this is pretty much everything that we have done within the terminal as well as through the GUI. But this would be a good template for a very standard PBS submission script. So here, just to go through the script, we are, all PBS submission scripts start with this line. We have to specify the resources that we want, right? So these are general. For this example, we're only requesting one node and one processor per node. So PPN, processor per node, wall time, 2 minutes, super quick job. And then memory. So in this case, it's processor memory. So you would take this number times PPN for your total memory. Again, small job, we only need limited resources, 1 gigabyte, and the -A flag for the open allocation. Cool, so this is, as you can see, the rest of the job submission script is basically everything that we've gone through. So module purge, module load MATLAB, you can see those are the commands that we executed. You know, in our current working directory, run launch MATLAB, and then go ahead and run the hello world MATLAB script and write the output to that log file. All right, so how do we get that job submitted? For those following along, we should be on slide 38, starting with the QSub command. So QSub, and then the PBS submission script name. So in this case, it should be MATLAB _ job PBS. And go ahead and execute that with the enter command. So as you see, the scheduler comes back and says, hey, your job's gonna run under the open account as you requested. It's kind of queued up in the scheduler, and we just kind of wait until those resources become available. And once those resources do become available, they become dedicated to our job, and then they go ahead and run and do their thing. So for those of you that are like, well, let me check on my job. Let's see. You can do a qstat -u your user ID. Of course, I've got a couple of other jobs running, and where? Okay, so you can see that my MATLAB job is queued up. So that queue status shows that it's queued. So the scheduler is kind of doing its thing, looking for those resources. Once it's done, it will place it on the nodes. Yeah. So while our jobs are all waiting to be placed on resources and run, we'll come back to this. But I do want to go over the final slides wherever we may be. So let's stop or swap back here. Hopefully you can see my slides.
Yeah, I can see it.
All right, thank you. So one thing that I put in here that I don't think is relevant to many users is using X11 forwarding through a terminal client. So I kind of want to like bypass that. But that QSub command on this slide, take out the X flag. So second line down, the QSub. So this is how you can, thinking back to when we just popped on Open On Demand and we issued the interact command. It basically gave us the same type of job. So it took us from a login node to a compute node, and it allows us to interact with our code just like we did for the second MATLAB example. You can run things through, debug, all that fun stuff. You can see it live, whereas the batch job is behind the scenes. So you can submit an interactive job using that interact command or this QSub command, removing the -x flag. And again, these are just ways that you can request a specific amount of resources, you know, relevant to your job. And you know, you can SSH into the cluster using X11 forwarding with the -y flag for those that's even relevant for. So this is a data transfer example. I'm not going to go through it, but you certainly can. So this kind of just starts off where we left off. In terms of like, hey, cd ... That's going to take you up 2 directories. You can go ahead and tar. What that tar command is doing is it's saying, hey, tar the new user directory into new user -training, whatever, tar, whatever. The new user, the output is actually what's provided underneath. And then if you issued the ls command, you would see that tar ball that was created within your work directory. And then you can go through and download it, just like I showed you how to download a file on Open On Demand. All right. Let's see what's up with our job, because I do want to leave some time for questions, even though you guys have been really quiet. Maybe you'll have some questions for us. Okay, back to our jobs. All right, so I'm going to rerun that Q stat, and it looks like my job is in a C status. So that must mean that it completed. Clearing my screen for all of you, I'm going to run LS. All right, cool. So I've got, output from my job. So it looks like my job completed. I'm going to do a cat on the log.matlab run file. So again, you can kind of see like, oh, it did everything that it did when I worked through the GUI, when I worked through the terminal through like more interactive type mode. So go ahead and look at the output files. Sometimes errors are generated through your job. If you're lucky, you'll capture those errors in an output file. Check out your, the output, the files that were produced during that job submission. All right, cool. So hopefully you guys, for those of you that had never submitted a batch job, hopefully you were able to successfully run that. I remember the first couple of times when I submitted a batch job and was like, I'm not sure if that worked. It's kind of nerve-wracking. But then once you figure it out and you actually get results, especially results that you're looking for or hoping for, it's really exciting. So have fun playing around with things. I would be happy to share lots more examples because we certainly have them in the iAsk Center. Swapping back over to the presentation, getting help, right? So super important. We are in the process of updating our user guide, but there's a lot of resources in the user guide. Good reference points, sample PBS files, sample, other files where you can work through different types of applications. We also have on-demand videos of past training series. So I think there's another new user training that was done by somebody different, so you might get a different perspective. Also, other training series that we've done. And then we have a YouTube channel. So check out those resources. As much as, I love online resources, right? I like to dig into things myself, but I also want to emphasize that our team is here to help you. So the iAsk Center, while, oftentimes you'll get either me or Chad or one of our graduate assistants, Jason, whomever, if it goes beyond our level of expertise, we most definitely do, or even access or permissions, we most definitely do escalate those tickets. So please don't hesitate to reach out to us. So next up, we have getting your software up and running on ICDS-ACI, which is next week. So you can register for these training sessions at the same spot you registered for the new user training. I would be more than happy at any point if you have any questions about the presentation, along with my team to answer whatever questions you have, right? Because most of us have specific use cases that we just can't touch on all of them. So we set up one-on-ones with folks. We have done more targeted new user training for different colleges, which kind of gets your users up and running in the direction that they need to go. Also, we have iAsk holds Zoom sessions, usually 3 to 4 a month. Those are open office hours, pop in at your leisure. We also have Zoom sessions where you can kind of schedule on demand. You submit a form and we try to get to you as quickly as we can. At this point, I think that's it. If anyone wants to unmute themselves, I know, unfortunately, as the presenter, I don't really get to see the chat while I'm presenting. So I basically talked for an hour and a half straight and tried to see if we had any questions, but it seems like Jason and Chad and Justin did a good job answering them. Any questions, comments? You guys really are quiet. Hopefully you're not sleeping. I'll go ahead and stop my share. Okay.
Hello, I don't have a question, but I just wanted to say this was a really excellent overview, super helpful for a lot of different backgrounds. So thank you so much. These are great examples and we have a good idea of where to go to next for more information. So thank you everyone who was involved.
Thank you, Kareem. Thank you for the feedback. I'm so glad that you found it informative and helpful. Well, thank you all so much for attending. If you didn't get the chance to, but would like the recorded version, again, I'll follow up with you after the presentation. Just pop your email in the chat. It sounds like Jason had gotten some of them during the presentation, but for anyone that didn't have the opportunity, we'll gather your email from the chat and we'll get that out to you this afternoon.